Okay, thank you so much, Kennedy, for joining me yet again for another exciting episode of the HIV Cure podcast, where we're just breaking down HIV science and just what's happening with HIV cure and cure strategies that are there. Yeah, today we're talking about HIV cure strategies, and one of those strategies is the shock and kill versus the block and lock. So don't worry about all these words. Kennedy will be explaining more on that. Hi, Kennedy.
Hi, Sakabo. Glad to have me back on your podcast. I'm happy to be here.
All right. Thank you so much. And today we're going to explore the innovative strategies that the researchers are using to tackle HIV reservoirs as well as latency, which you will explain more on that. They're promising when it comes to a potential a cure and also integrating them to the existing ARV treatment or ART as well as the HIV vaccines. So yes, thank you so much, Kennedy. And first and foremost, I mentioned a few words that are a bit heavy. I talked about HIV reservoirs and latency, and I just want you to explain to us what are these HIV reservoirs and why do they pose such a significant challenge in achieving an HIV cure?
Wow, that's a mouthful of a question. So let me. So okay, HIV reservoirs are just like hidden valves of dormant virus, rested within certain cells in the body, immune cells such as the CD4 cells, okay, or the T cells, CD4 T cells. So these reservoirs, are formed early in infection and persist even with ARVs, even with ART. Okay, so the virus lies dormant, escaping detection by the immune system and ART, which targets actively replicating, HIV. So ART and the immune system usually looks for an active uh, infected cell, the one that is replicating. If it's dormant, then it's invisible from the immune system and ART. So the challenge is that if ART is stopped, okay, and this is the key thing, if ART is stopped, these reservoirs can reactivate, leading to a viral rebound, called a viral rebound, meaning the once dormant infected cells, now they are actively replicating. Okay, so this latent state makes it incredibly difficult to achieve a cure because you are dealing with a virus that can hide for years or even decades.
So then now can you please explain the basic concept of the shock and kill strategy and how it works to target the dormant HIV that you just talked about?
So good. So the shock and kill. Wow. When I first heard about this term, I was like, wow, this is shock. The shock. You touch naked power cables, the way they shock you, and yeah. So that's what came to my mind many years ago when I started got into the space of HIV cure research. So the shock and kill strategy actually aims to flush HIV of out of its hiding place. Okay? So the shock, the shock involves activating. It means the shock. For now, I'm breaking down the shock. Then I'll talk about the kill later. So the shock involves activating the latent virus in these reservoirs, forcing it to begin to replicate and expose itself. So once active, the immune system or the ARVs that we get, or the therapies that agents can now then move into kill. Okay? I'm now moving to the kill part. To kill the infected cells, ideally eliminating the reservoir altogether. So this strategy relies on sophisticated tools working the virus without causing widespread immune activation or inflammation. So that's another challenge in this strategy. So the ultimate goal is to eradicate the reservoirs and clear HIV from the body completely. In a nutshell, that's what.
Oh, okay. That sounds like, yes, I want that today. And we're just going to find out more on why I can't get it today, because I really do. I mean, just eradicating, removing everything, and then I'm just Sakabo without an HIV. That is something that I want, like, immediately. And then now we want to know about the block and log strategy or part, like how does it work and how does it differ from the shock and kill that you just explained, and why might it be considered a bit safer or more a complementary approach?
So yes, so besides the shock and kill, now we'll talk about the block and lock strategy. So the block and lock strategy actually takes a different approach, okay, than the shock and kill. It does not try to awaken the virus, okay? What it does instead is it aims to keep HIV permanently dormant, not to awaken it, just permanently dormant. Permanently, but dormant. So the block phase ensures that the virus cannot reactivate, while the lock phase, actually, in simple terms, works to solidify this latency, essentially locking the virus in a non-replicating state. So this strategy may be safer because it avoids potential risks of reactivating the virus, such as inflammation and immune system damage. So it's also seen as a complementary to shock and kill because it focuses on containment rather than elimination. You understand? It just tries to contain infected cells rather than eliminating them, making it a viable option for a functional cure.
Okay, so it's more like having a sleeping HIV in my body.
And permanently sleeping.
Yes. Okay, that also sounds like a good option. So
yes,
then, yeah, I mean, I think, science is so amazing to see how people are able to discover these things, try them out, and also, even though they are challenges, but they are working towards something, and they can have, or there's something tangible that they can show us now. And now we want to know, like, in terms of the scientific tools and as well as the methods that are used for to shock HIV out of from its latent state, and how effective have they been in clinical trials?
So the shock, to shock HIV, researchers use what we call LRAs. So this means latency reversing agents. Okay, these include drugs like histone, deacrylic inhibitors. I think this, because now in communities, they don't mind much about that, but what they should just take into their mind that the researchers are using what we call latency reversing agents. Okay, these agents work by disrupting, the molecular mechanism that keep HIV dormant, then so that it can work. So while some latency reversing agents have successfully reactivated the latent HIV in the labs, okay, and in small clinical trials, their effectiveness has been limited. Incomplete activation, okay, others they don't reactivate of the reservoirs, and the risk of overstimulating the immune system, okay. So they have to balance between this and overstimulating the immune system. So these are some of the challenges that we have.
Okay, so what challenges now have researchers faced in the kill phase of the shock and kill strategy? And also, are there any risks of now harming healthy cells when you are using this strategy of um, shock and kill?
So once HIV is reactivated, the immune system or therapeutic agents, must efficiently, I underline the word, efficiently eliminate the infected cells. You have woken them up. You should also eliminate them. They were sleeping.
Yeah.
So kill them. Okay. However, the response may not be strong enough sometimes. And some therapeutic agents risk, damaging health cells as well. So, for example, a type of immune cells called the T cells may struggle to identify and destroy all reactivated cells. So researchers are also exploring immune-enhancing therapies like therapeutic vaccines or monoclonal antibodies to boost these processes, while minimizing, that what I call collateral damage. It's like you see a thief in the house, you want to smoke out the thief, then you completely destroy the whole house, because the thief is inside. You should select the thief, smoke the thief alone, and leave the house intact. So, yeah.
Okay. Now we want to see the results, or you want to know about the results, and what are some of the key successes or breakthroughs in the block and lock approach, and how do researchers ensure that the HIV stays dormant, like it stays sleeping until the end of time?
Wow. And that's what I'm looking for. So, one of the major breakthroughs, I think, in the block and lock approach involves small molecules, or what we call gene editing tools like CRISPR. Okay. Sometimes I will use these terms. I want also young listeners, young advocates. We can't offload all the information here. Okay.
Yes.
So some of these things you need to. Kennedy talked about CRISPR or gene editing tools. Let me go and research on my own.
Yeah.
Okay. Yeah. So we also encourage people to go and research on their own. So the block and lock approach involves small molecules or gene editing like CRISPR, which can modify the DNA of an HIV infected cell to keep the virus locked in its latent state. Some compounds target pathways that the virus uses to reactivate, essentially trapping it in dormancy. Okay. So researchers are also testing long-acting formulations to maintain latency over extended periods. And also successes in preclinical models have shown that, this strategy can significantly reduce the risk, of viral rebound.
So you've explained it so beautifully and using simple analogies like the thief and the house. And I hope that now people are able to understand. And now we want to know, with the shock and kill, as well as the block and lock strategies, how these strategies, how can we make them work alongside the current antiretroviral therapy to improve the outcomes for people living with HIV?
Yes. So both strategies could enhance ART. So ART is antiretroviral therapy. So both strategies could enhance ARVs by addressing the limitation of current treatment. So ART suppress, viral replication, but doesn't target reservoirs. We know that. So combining ART with shock and kill could help clear the reservoirs, while integrating block and lock could prevent reactivation of any remaining viruses. Okay, so these approaches could pave way for treatment simplification, meaning potentially reducing the need for lifelong ART and improving the quality of life for people living with HIV.
And I also know that you read a lot of research papers and always encourage everyone to read, but I know that there are people who don't like reading, or they say that no, some of these papers are too complicated, I don't even understand. But like you said, that the listeners should now go and find out about these words when it comes to like gene editing. What is gene editing? All these words to understand, and then through that now, and also through these podcasts, we're able to also just empower them to know about some of them, and also just open up that interest to read research papers. And with that, from all the reading that you've done, all the curiosity that you went about reading and Googling stuff on HIV cure, have there been any notable cases or success stories where these strategies have been tested, and what are the results saying?
So yeah, there are a few notable. So yes, there have been several notable cases. For example, latency reversing agents used in the shock and kill strategy have shown partial success in reactivating latent HIV in clinical trials, though complete eradication remains, elusive. So in block and lock space, a study involving the drug, there's a drug called DCA, okay, demonstrated its ability to block HIV reactivation in laboratories. These are in laboratory settings, guys, meaning in research. So these early results highlight the potential of these strategies, though much work, a lot of work remains to translate them into clinical cures.
On the previous episode, we talked about BNABs and also BNABs and vaccines. So now, what role could vaccines play in enhancing the effectiveness of either the shock and kill strategy or the block and lock strategy?
Yeah, and this is an area that we also need to follow up. This kind of research that we, as activists and advocates, need to begin to follow up. So vaccines could play a critical role, okay, by boosting the immune system ability to identify and destroy HIV-infected cells during the kill phase of the shock and kill. So therapeutic vaccines can train the immune system, or actually to recognize and target the virus more effectively. Okay. While for block and lock, vaccines could enhance immune surveillance, ensuring that any attempt by HIV to reactivate are swiftly neutralized. Okay, so this combination of strategies could provide a powerful, very powerful signage in the fight against HIV.
All right. So just to, in closing, we now want to know that how are the researchers working to address the ethical and safety concerns involved in using these experimental approaches on humans? Because now we know that when it comes to ethics, and people now are saying that no, some of these can only work in the lab, and we don't want to be involved in this.
Humans, yeah. I mean, yeah, when you hear about, strategy in the lab, yeah, well, they only involve samples. But when you get into humans now, it's a different ballgame together.
Yeah.
Because now you are dealing with a live or a living human being. So ethical and safety concerns usually are a top priority when you come to that. So clinical trials, for shock and kill and block and lock usually are conducted under very strict regulation. So oversight with comprehensive risk assessment and patient monitoring. You see, maybe next time we'll talk about analytical treatment interruption, one of the episodes. So these are all issues that come with ethical considerations, strict ethical considerations. So additionally, preclinical studies are meticulously, designed to minimize. And you see what it is, only the most promising and safe approach usually progresses to human trials. Okay? So when they see, they determine that, this approach is risky to get it to humans. It will not come to humans. So this ensuring that informed consent and maintaining the highest ethical standards are central to all these efforts. So most of these approaches adhere to very strict ethical standards. So nothing is 100% safe. Well, that's why they are called trials in the first place.
Mm-hmm.
It can't be 100% safe, but the scientists or researchers ensure that these approaches, these trials are safe for humans to take part in as study participants.
Thank you so much, Kennedy, for yet again joining us to explain the science behind some of the HIV cure strategies. Today, we're talking about the shock and kill versus the block and lock strategy when it comes to us working towards an HIV cure, and also just involving, going into clinical trials, the fear that is there, and but most importantly, the potential of using this strategy to an HIV cure.
Thank you so much, Sekabo. Please continue doing the good work. We hope people will begin to get interested. We need also to encourage young people who do well in sciences to consider getting into it's very exciting. Thank you so much for having me.
All right. Thank you so much. And please join me for next time for another exciting episode of HIV Cure, where we will be unpacking more issues or more strategies in HIV Cure and where we stand or where we are when it comes to having a functional HIV cure.
Thank you so much, Sakawa. I'm just a click away.